Okay, guys, I'm going to work on number two now. So for number two, we can see that it gives us a velocity versus time graph, but it doesn't give us any of the other things. So let's start off first. Let's think about what this velocity versus time graph means. So I know I've got two sections here. I've got section one. Oops, I don't want to do that. Let's make that a highlighter. So I've got section one here, and then I've got section two. Um, and section one, so first off, we have to notice that they're both negative. So remember that below the line, below the line means negative velocity, and that means that the motion is moving back towards zero, not away from zero. So I kind of like to do this, guys. Let's just do this. Let's go ahead and write our verbal description first. So right away, I know, okay, so object is moving toward zero at -3 meters per second. Let's go down here. All right, and so let's talk about how I know that. So I look up here and I see that, and I know it's not labeled. That's okay. I'm just going to call it -3. So it's moving towards zero at -3 meters per second. Now the important thing to notice here, all right, is that when it goes from down there to up, so from lower to higher, on this graph, that means that it slows down. So remember this, we talked about this in class. As velocity graphs get higher above the axis, they're getting faster. As they get farther below the axis, they're also getting faster. So it's kind of reverse. So that means that this one is faster than this one because it's farther away from the axis. So the farther away from the axis you go, the faster the motion. All right, so let's erase all that. Okay, so let's go back to what I was writing. So I said that the object is moving towards zero at -3 miles per hour. Then it slows down to -1 meter per second, and it does that at 4 seconds. Okay, so there we go. Object's moving towards zero. That's how we know, it's because it's negative. That's how we know it's towards zero, okay? At -3 meters per second, then it slows down to -1 meter per second at 4 seconds, okay? So let's think about, now I said we didn't need to label this thing with numbers, and that's okay. I think I like that. Let's not label it with numbers, but we know that in general, it's going to need to go something like that. It's going to need to go that direction because it's going from some position up here. I don't want to make it zero. Okay, so it's going from something up here, and it's going down towards zero. So let's think about that. So it starts going fast. So let's just go ahead and make a line. Let's make a line that's going downhill and pretty steep, okay? So we know that it's going to go like that for here. It's going to go about 4 seconds. So let's draw it again. So it's going to go about 4 seconds, pretty steep. And then suddenly it's going to not be quite as steep. That's because this section here is fast, and this section here is slow. And we got to remember here that steeper equals faster. Okay. Steeper equals faster. All right, cool. So we got two. We got our written description. We got x versus t. Let's just draw our motion diagram. Now, let's remember that every good motion diagram starts off with an axis. The axis has to have a zero. Okay, now, our other motion diagram had arrows going that way. But that was when the motion was moving away from zero. Now the motion is moving towards zero, so our arrows need to go from left to right. So I'm going to start over here on the right side and just put a dot. Now I know that it's going fast to start with, so I want pretty long arrows to start with. And then I know that it slows down, so I'm going to make short arrows in the second half. Okay? So I start off long, that means it's going fast, and then they get short, that's when it's going slow. And they're all going from right to left because it's going towards 0. We know it's going towards 0 because our velocity is negative. It's below the line. That means it's got to be going back towards 0. All right. Hey, that's it for number 2.